When installing tanning beds, several code requirements and best practices should be followed to ensure safety and compliance. NFPA 70, which is the National Electrical Code or NEC, Article 680 covers lighting fixtures including tanning beds. IEC 60335-2-27 is an international standard that specifically addresses tanning beds. Regarding protection and disconnection, NEC 680.43b states that tanning beds must have a disconnect switch within sight of the tanning unit. NEC 423.31 reinforces this by stating that if the tanning bed is hardwired, a disconnect switch must be located within sight of the bed. However, NEC 404.7c offers an alternative. If the switch or timer is within sight of the bed and controls the entire unit, it can serve as the disconnect. As for wiring, NEC 680.31 mandates that the branch circuit supplying the tanning bed shall be sized for the maximum current draw. NEC 250.122 requires the circuit to be protected by an overcurrent device rated for the circuit's ampacity. NEC 400.3b confirms that a three-phase panel with 120/208 volts is acceptable for tanning bed installation. Additional considerations include ensuring the wiring is properly sized and installed to handle the high amperage draw. Each tanning bed should have a dedicated circuit. Proper ventilation and cooling for the tanning beds are also crucial. Always follow the manufacturer's instructions for installation and operation. It is recommended to install a disconnect switch at each tanning bed location, even if the switch or timer controls the entire unit. This ensures easy access to the disconnect in case of an emergency. In summary, the key points to consider are firstly, adhering to NEC Article 680 which governs lighting fixtures, including tanning beds, and IEC 60335-2-27, the international standard for tanning beds. Secondly, ensuring that a disconnect switch is within sight of each tanning bed, as specified by NEC 680.43b and NEC 423.31. If a switch or timer meets the requirements of NEC 404.7c, it can serve as the disconnect. Thirdly, sizing the branch circuit according to NEC 680.31 to handle the maximum current draw and protecting it with an overcurrent device as per NEC 250.122. Fourthly, verifying that the three-phase panel with 120/208 volts is suitable for the tanning bed installation according to NEC 400.3b. Fifthly, installing dedicated circuits for each tanning bed to manage the high amperage. Sixthly, providing adequate ventilation and cooling for the units. Seventhly, always consulting and adhering to the manufacturer's installation and operation instructions. Lastly, installing a disconnect switch at each tanning bed for emergency situations. When sizing conductors for the tanning beds, begin by determining the total amperage draw for each unit. In the example provided, the tanning beds pull 70 amps, 40 amps, and 30 amps, respectively. Using this information, you can refer to NEC Table 310.16 to determine the appropriate conductor size based on the ampacity. For example, for the 70 amp unit, you would need conductors rated for at least 70 amps. Depending on the insulation type, this might require number 4 American wire gauge or AWG copper conductors, but always verify with the specific table based on the insulation temperature rating and installation conditions. The overcurrent protection device, such as a circuit breaker or fuse, must be sized appropriately to protect the conductors and the equipment. According to NEC 240.4, the overcurrent protection device should be sized to protect the conductors in accordance with their ampacity. However, NEC 210.20 also specifies that the overcurrent device should not exceed the rating of the tanning bed itself. For the 70 amp unit, a 70 amp overcurrent device would typically be suitable, provided that the conductors are also rated for at least 70 amps. If the tanning bed's nameplate specifies a maximum overcurrent protection rating, that value should not be exceeded. The disconnect switch serves as a means to safely de-energize the tanning bed for maintenance or in case of an emergency. As previously mentioned, NEC 680.43b requires the disconnect to be within sight of the tanning unit. This means it must be readily accessible and visible from the tanning bed location. The disconnect switch must be rated for the voltage and current it is expected to carry. For a 70 amp unit operating on a 208 volt circuit, a disconnect switch rated for at least 70 amps and 250 volts would be appropriate. Ensure the disconnect switch is horsepower rated if it is used to switch motor loads, although tanning beds typically do not have significant motor loads. The grounding and bonding of the tanning beds and associated electrical equipment are critical for safety. According to NEC 250.110, all exposed non-current carrying metal parts of electrical equipment must be grounded. This includes the metal frames of the tanning beds, the enclosures of the disconnect switches, and any metal conduit or raceways. The grounding conductor must be sized in accordance with NEC 250.122, based on the size of the overcurrent protection device. For a 70 amp circuit, a number 8 AWG copper grounding conductor is typically required. Bonding ensures that all metal parts are electrically connected to create a low impedance path for fault current. This helps to trip the overcurrent protection device quickly in the event of a ground fault, minimizing the risk of electric shock. All grounding and bonding connections must be made using approved methods and hardware. When dealing with a 3-phase 120/208 volt panel, it is essential to ensure that the tanning beds are properly balanced across the 3 phases to prevent overloading any one phase. The 70 amp, 40 amp, and 30 amp unit should ideally be connected to separate phases to distribute the load evenly. Use a clamp meter to measure the current on each phase to verify that the load is balanced. If one phase is significantly more loaded than the others, it may be necessary to redistribute the loads to ensure proper balance. Unevenly loaded phases can lead to voltage imbalances, overheating, and potential equipment damage. The National Electrical Code provides specific guidelines for wiring methods and materials that must be followed for safe and compliant installations. For example, NEC 300.3b requires that all conductors of a circuit, including the neutral and grounding conductors, must be installed in the same raceway or cable. This helps to minimize impedance and ensure proper operation of the overcurrent protection device. NEC 310.15 specifies the allowable ampacities of conductors based on their size, insulation type, and installation conditions. It is crucial to select conductors that are rated for the appropriate temperature and environment to prevent overheating and insulation breakdown. When running conductors through walls or ceilings, ensure they are protected from physical damage by using conduit or other approved methods. When making connections to the tanning beds and disconnect switches, use properly sized and listed connectors and terminals. Ensure that all connections are tight and secure to prevent overheating and arcing. Follow the manufacturer's instructions for terminating conductors and tightening screws. Regular maintenance and inspection of the electrical system are essential to ensure continued safe and reliable operation. Schedule periodic inspections by a qualified electrician to check for loose connections, damaged wiring, and other potential problems. Thermographic scanning can be used to identify hotspots caused by loose connections or overloaded circuits. Replace any worn or damaged components promptly to prevent failures and potential hazards. Keep the area around the tanning beds and electrical equipment clean and free of obstructions to allow for proper ventilation and access for maintenance. When installing electrical equipment in commercial settings, it is important to comply with the Americans with Disabilities Act or ADA requirements for accessibility. Ensure that disconnect switches and other controls are mounted at a height that is accessible to individuals with disabilities. Provide adequate clearance around electrical equipment to allow for easy access and maneuverability. Consult the ADA guidelines and local building codes for specific requirements. The International Electrotechnical Commission or IEC standards provide additional guidance for the design, construction, and testing of electrical equipment, including tanning beds. IEC 60335-2-27 specifically addresses the safety requirements for tanning appliances for household and similar purposes. This standard covers aspects such as protection against electric shock, fire, and mechanical hazards. Complying with IEC standards can help ensure that the tanning beds are safe and reliable. Regular training for employees on the safe operation and maintenance of tanning beds is essential to prevent accidents and injuries. Provide training on how to properly use the equipment, recognize potential hazards, and respond to emergencies. Emphasize the importance of following safety procedures and wearing appropriate protective equipment. Keep records of all training sessions and ensure that employees are updated on any changes to safety procedures or regulations. Working with electricity can be dangerous, and it is essential to take precautions to protect yourself from electric shock and other hazards. Always de-energize circuits before working on them and use lockout/tagout procedures to prevent accidental energization. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Use insulated tools to prevent contact with live conductors. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Before starting any electrical work, it is important to obtain the necessary permits from the local building department. This ensures that the work is inspected and complies with all applicable codes and regulations. Provide detailed plans and specifications to the building department and be prepared to answer any questions they may have. Schedule inspections at appropriate stages of the work and address any deficiencies promptly. Failure to obtain permits can result in fines and delays. Electrical installations must comply with all applicable federal, state, and local codes and regulations. These codes are designed to ensure the safety of people and property. Stay up to date on the latest code requirements and consult with a qualified electrical inspector to ensure compliance. Failure to comply with codes can result in fines, penalties, and potential liability. Proper planning and design are essential for a safe and reliable electrical installation. Consider the current and future needs of the facility and design the electrical system accordingly. Use appropriate software and tools to calculate loads, size conductors, and select equipment. Coordinate the electrical design with other building systems, such as mechanical and plumbing. Review the design with a qualified engineer or electrician to ensure accuracy and completeness. A well-designed electrical system will provide years of trouble-free service. Regular inspections of electrical equipment can help to identify potential problems before they become serious. Look for signs of overheating, such as discolored insulation or melted components. Check for loose connections or damaged wiring. Inspect the grounding system to ensure that it is intact and effective. Replace any worn or damaged components promptly. Regular inspections can help to prevent electrical fires and other hazards. Electrical fires can be caused by a variety of factors, such as overloaded circuits, loose connections, and damaged wiring. Install smoke detectors and fire alarms to provide early warning of a fire. Keep fire extinguishers readily available and train employees on how to use them. Store flammable materials in approved containers and away from electrical equipment. Have a fire evacuation plan in place and practice it regularly. Preventing electrical fires is essential to protect people and property. The use of arc fault circuit interrupters or size can help to prevent electrical fires caused by arcing faults. Size are designed to detect arcing faults, which are a common cause of electrical fires, and to trip the circuit breaker before a fire can start. NEC 210.12 requires a size to be installed in many areas of the home, such as bedrooms and living rooms. Consider installing a size in other areas of the facility to provide additional protection. Surge protection devices or SPD can help to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other factors. SPD are designed to divert excess voltage away from sensitive equipment, preventing damage. Install SPD at the service entrance and at individual pieces of equipment to provide comprehensive surge protection. Energy-efficient lighting can help to reduce energy consumption and save money. Replace incandescent light bulbs with LED light bulbs, which use significantly less energy and last much longer. Install occupancy sensors to turn off lights when they are not needed. Use daylight harvesting to reduce the need for artificial lighting. Energy-efficient lighting can also reduce heat gain, which can lower cooling costs. Uninterruptible power supplies or UPS can provide backup power in the event of a power outage. UPS are commonly used to protect computers and other critical equipment from data loss and damage. Select a UPS that is sized to handle the load of the equipment it is protecting. Test the UPS regularly to ensure that it is functioning properly. An uninterruptible power supply can provide peace of mind knowing that critical equipment will continue to operate during a power outage. Harmonic distortion can cause problems in electrical systems, such as overheating, equipment malfunction, and reduced power quality. Harmonic distortion is caused by nonlinear loads, such as electronic ballasts and variable frequency drives. Use harmonic filters to reduce harmonic distortion. Perform a harmonic analysis to identify the sources and levels of harmonic distortion. Reducing harmonic distortion can improve the efficiency and reliability of electrical systems. Power factor correction can improve the efficiency of electrical systems and reduce energy costs. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased energy consumption and higher utility bills. Use power factor correction capacitors to improve the power factor. Perform a power factor analysis to determine the appropriate size and location of the capacitors. Improving the power factor can save money and reduce the strain on the electrical system. Variable frequency drives or VFD can be used to control the speed of motors and reduce energy consumption. VFD are commonly used to control the speed of fans, pumps, and compressors. By reducing the speed of the motor, the VFD can reduce energy consumption and extend the life of the motor. Select a VFD that is sized to match the motor and the application. Use a VFD to optimize the performance of the motor and reduce energy costs. Proper labeling of electrical equipment can help to prevent accidents and make it easier to troubleshoot problems. Label all circuit breakers, disconnect switches, and other electrical equipment with their function and voltage. Use clear and concise labels that are easy to read. Update the labels wherever changes are made to the electrical system. Proper labeling can improve safety and efficiency. The use of ground fault circuit interrupters or GFCIs can help to prevent electric shock. GFCIs are designed to detect ground faults, which can occur when electricity leaks to ground. When a ground fault is detected, the GFCI trips the circuit breaker, preventing electric shock. NEC 210.8 requires GFCIs to be installed in many areas of the home, such as bathrooms and kitchens. Consider installing GFCIs in other areas of the facility to provide additional protection. Always follow the manufacturer's instructions for installation, operation, and maintenance of electrical equipment. The manufacturer's instructions provide important information about the proper use of the equipment and can help to prevent accidents and equipment damage. Keep the manufacturer's instructions readily available and refer to them whenever you have questions. Following the manufacturer's instructions is essential for safe and reliable operation. Regular training for employees on electrical safety is essential to prevent accidents and injuries. Provide training on the hazards of electricity, safe work practices, and the proper use of personal protective equipment. Emphasize the importance of following safety procedures and reporting any unsafe conditions. Keep records of all training sessions and ensure that employees are updated on any changes to safety procedures or regulations. Regular training can help to create a safe work environment. A written electrical safety program can help to ensure that electrical safety practices are followed consistently. The electrical safety program should include policies and procedures for lockout/tagout, confined space entry, and other electrical safety hazards. The electrical safety program should be reviewed and updated regularly. Implementing a written electrical safety program can help to reduce the risk of electrical accidents and injuries. Always assume that electrical circuits are live and take appropriate precautions. Never touch exposed wires or electrical components. Use insulated tools and wear appropriate personal protective equipment. Work with a qualified electrician when performing electrical work. Taking precautions can help to prevent electric shock and other hazards. By following these guidelines, you can ensure the safe and compliant installation of tanning beds and protect yourself and others from electrical hazards.